Hello everyone. Today I am going to discuss about the topic is called as a ionic equilibrium. So total full chapter I will explain in a series of videos. So here we can see this one mainly what is meant by ionic equilibrium. I will explain. I will include the previous IIT and NEET papers. I will provide the practice papers also. So here you can see ionic equilibrium means the equilibrium is established when a substance is when you are dissolved in the water. Some of the parts of the substance is dissociated, some of them is not undissociated. The equilibrium is established, that is called as a ionic equilibrium. So here in the ionic equilibrium, some important terminology we have to learn here. So here you can see based upon the dissociation, classification of the substance. This is the important one we have to remember. So what is meant by classification of substance here? First classification is electrolyte. What is meant by electrolyte? Electrolyte means these are the substance when we are dissolving in the water which dissociated into components ions where they formed components ions. What are the example you can see the compound containing the ionic bonds most probably, for example NaCl and the KCl like this. Second example, polar covalent bond containing the compounds like HCl. Next one, non-electrolyte. So what is meant by non-electrolyte? Non-electrolyte means these are the substance when we are dissolving in the water, they will not dissociate it. So which does not dissociate into component ions. Component ion. What are the example? Non-polar covalent bond. For example, you can see here urea, glucose and sucrose. They will not dissolve in the water. They will not release the H plus ions. That's why they will not conduct the heat and electricity. These are non-electrolyte. They will not dissociated into particular ion. That's why this is our non-electrolyte. So next one, again electrolyte classified into two types they are classified. So classification of electrolytes are classified into two types. One is called as a weak electrolyte. Second one is called as a strong electrolyte. Now you can see the example of what is meant by strong electrolyte. Strong electrolyte in the sense when we dissolve in the water, completely it will dissociated. This means completely 100% ionized. 100% ionized. If you take 100 molecule, 100 percentage, for example, you are taking some concentration, total concentration dissociated into component. That means whose alpha is equal to 1. In this chapter, we will degree of dissociation we are calling it as a alpha. How much it is dissociated? Dissociation we are using the symbol is called as a alpha. When alpha is 1 in the sense it is completely dissociated. That's we have to understand. Here you this type of strong electrolyte you will see this one, no equilibrium established. No equilibrium established here. So here for example I am taking the one substance that is called as a strong electrolyte. When I am dissolved in the water it will become AB aqueous. So it will dissociate it into A plus aqueous plus B minus aqueous here. You can see one is single arrow. That means completely dissociation is happen. AB completely converted into A plus and B minus. So initially if you see at the time of T is equal to 0, AB concentration is C. A plus concentration is 0, B minus concentration is 0. At the end I am talking about. That means at the end of the reaction, AB is completely dissociated. You cannot see the AB, but you can see the A plus is C concentration, B is C concentration. How much you are taking, that much only particular ion will be formed. Any ionic concentration in the given question in the equilibrium, stoichiometric coefficient is 1. So that time no, we can go with the concentration is equal to C alpha only we are going. We can, with the help of this one, we can easily calculate. What are the example? If you see the example of the strong electrolyte, all strong bases comes under the this category. What are the strong bases? You can see HClO4, you can see H2SO4, HNO3, HI, HBr, HCl. These are the example. But maximum here we will discuss in this chapter about the H2SO4. Next one, this is strong acids, strong acid. Next one you can see strong bases. Strong bases, generally when the metallic character is increases, basic character will be increases. Based upon this strong bases, sodium hydroxide, this is also will discuss in this chapter more. KOH, RbOH, rubidium hydroxide, cesium hydroxide, calcium hydroxide, strontium hydroxide. Next one, barium hydroxide. Next, when it comes to the salt category, NaCl, which is formed by the strong acid and the strong base. Next one, CH3COO Na, weak acid and the strong base. NH4Cl, weak base and strong acid. Next one, CH3COO NH4, weak acid and weak bases. This is about the strong electrolyte. When it comes to the weak electrolyte, weak electrolyte in the sense whose alpha is unknown, that means alpha is less than the 1, that means it will not completely dissociate, only few portion is will be dissociated. For example, if I take AB aqueous, I am taking here, when I am dissolving the water, it will become aqueous solution, it will dissociate, only some of the parts will be partially dissociated. You cannot see completely A plus, completely B minus, completely AB, only partially. That's why initial concentration is C here, here it is 0, it is 0. But at the time of the equilibrium, here I am talking about the equilibrium, from the concentration some of the portion will be dissociated. That's why I am calling it as a C alpha. Alpha is nothing but degree of dissociation, how much percentage it is dissociated. C is nothing but concentrated. Here it is also C alpha. Here how much? Not completely. Initially we have written 0, but here we cannot write the 0. Why? Because only partial dissociation is happened. So C minus how much it is initial minus how much it is dissociated. C minus C alpha will write. So what are the example? Example you can see weak acids. So when it comes to the weak acids, example HClO2, HClO, H2SO3, H2SO5, HNO2, hydrogen fluoride, and all organic acids. So here here you can see carbonic acid, H2S, acetic acid, and formic acid also will be there here. Next example, if you see weak acid, next weak bases. Ammonia related mainly we will discuss in this chapter. Ammonia and ammonium hydroxide. Otherwise ammonia derivatives. This means from the ammonia, if you remove the hydrogens and if you are adding anything group you are adding, let us say that CH3 and NH2. NH3 and all its derivatives are considered as a weak basis, that will comes under the weak electrolyte. So next video I will upload about the Arrhenius acid, Lewis theory of acid and bases, Brownstein acid and bases. Later I will discuss about the pH, all this I will discuss. So if you want this more videos, subscribe to my channel, share to your friends. Thanks for watching.